The objective for today, which I did insert and it's disappeared, is to convert from exponential form, I'll have to abbreviate, to logarithmic form, and logarithmic form to exponential form. Also, in some cases, to solve for a missing part. Logarithm, it's written out like this. Logarithms, that's what we're going to be doing now. That's that log button on your calculator. It's also the LN button, which is a natural log on there. Here's an example. Exponent form. Here is your base form of an exponent. So you have the base, you have an exponent, and then you have the result. Sometimes the variables change, but the position is what matters. This is logarithm form. Log base b of, always say the word of in between there, of x equals y. Remember, it was b to the y power equals x in the exponent form. You use the same components except you put them in different spots for logarithm form. Log base b of x equals y. If you can remember those two forms, then you have a 50% greater chance of doing well for this unit. A common log. Anytime you hear common log, it means you're going to see the word log by itself, and there's no base written there. If you see no base on a log, then the base is 10. No base means the base is 10. Otherwise, the base has to be written. This is a natural log, LN on your calculator, log natural. Now, with that one, if you see no base, that means that the base is E. Just like pi is 3.14, there's an E that's on your calculator, and it's equivalent to approximately 2.71. And it goes on out from there, but we usually use 2.71. If I tell you to use it from your calculator, then you just have to use the E from your calculator. If you look at your calculator, that E is located on the division sign. It's a lowercase e, and you would have to hit second in order to get it to come up. So if you hit second division and hit enter, that gives you the total value for E, 2.71828, and so on. Alright, so we have 3 squared equals 9. Here's a very basic example. 3 squared equals 9. You have a base, an exponent, and a result. As long as you know that in this form, the 3 is the base, the 2 is the exponent, and the 9 is the result, you'll be doing very well. So what we just had was 3 squared equals 9. If you write it in logarithm form, remember the base is 3, it goes there. Subscript. The result is 9, it goes there, and it equals 2, which was the exponent from the exponent form. Log base 3 of 9 equals 2. Okay, we're going to write 4 to the third equals 64 in logarithmic form. Log base 4 of 64 equals 3. If you can go from this, 4 to the third equals 64, to that, you're doing well. Go from log form to exponential form. So here's log base 2 of 32 equals 5. I want to go from the log form to exponential form. What is the base?
2.
Base is 2. What's the exponent?
5.
And the result?
32.
32. Now you can't just make these up. You can't put stuff like 2 to the 7th power equals 5. It has to be mathematically true. And 2 to the 5th power is 32. Find missing items from the log form. So I have log base 6 of x equals 3. And I have to figure out what's missing. So if I want to figure out what's missing, I can put it in exponent form and try to figure it out. So the base is 6. It's to the 3rd power. and it equals x. So on your calculator, you could figure out that x is what?
216.
216, yeah. So that's not too difficult. I forgot that I'd already worked it out, so oh well. Log base b of 81 equals 4. You know the base is b, and the exponent is 4. The result is 81. Now there is a way you can solve for this stuff with logarithms, but for now I'm just giving you problems that are easy enough to guess and check. Or in this case, you can actually do a quartic root and come up with 3. To undo b to the 4th, you need the 4th root of 81. And to put in the 4th root of 81 on your calculator, you would do this. Type 81, use a caret, parenthesis, 1 divided by 4, and then another parenthesis, and you can come back with 3. Log base 5 to the y power is 625. There is a way to solve this using logs, but we haven't made it that far yet. It's a little too soon. So I'm just giving you ones that you can guess and check on. 5 to what power is going to be 625? 5 squared is 25. What's 5 to the 3rd? 125. What's 5 to the 4th? 625. So the answer is 4. And we'll get into the actual solving method on that when the time comes. It's a little too soon for that. And that's exactly what I just said. Okay, here's some practice. Not enough time for practice, so we'll look at a couple of examples. So you have, like I told you before when I went to the screen and put the ACT book up there and hid the equal sign in the number. You have log base 2 of 64. What this really means is 2 to some power is going to be 64. What is that number? 2 to what power is 64?
2 to the 6th.
2 to the 6th, right. 3 to some power from this one. 3 to some power is 27. What number is that? 3 to the 3rd, so we put 3. And 4 to some power is 64. What power is that? 3. Now we came up with those by guessing and checking, and I've made these small enough. Notice these are not in the millions, so I've made it easy to check. So you have 6, 3, and 3. So if I added all of these expressions together, or whatever operation I had, in this case I would get 12 because I added 6, 3, and 3. In this problem, log base 2 of 16 plus log base 10 of 100. 2 to what power is 16?
2 to the 4th.
2 to the 4th. And 10 to what power is 100? Second power. So the answer is 6. So that nasty looking expression there can be all boiled down to just 6.